This assignment to do this evening. First one was question number 4. Asked you to go from 35 miles per hour. Let's see what that is in feet per second. So we're going 35 miles for every 1 hour. Okay, and we want to get that into feet per second. Okay, so what we're doing is we're trying to get this. This is the process every single time. Take that unit, and it's got to go down here, right? Okay. So then we're gonna have miles right there. And my goal then is once I know that those units are gonna cancel, the question is there a link between miles and the unit of distance that I have in my answer? Do you guys know a link between miles and feet? We should know it. How many feet are there in a mile? 5,280. Okay. So that gives me the correct conversion factor for miles into feet. So if I multiplied everything out right now, I would have an answer of feet per hour. Those are the only units that would be left. Well, that's not what I want here. So I need to think about how do I get hours then transformed into seconds. So, just like before, I'm going to start with hours, and it's in the denominator, so up here, hours need to show up in the numerator. For the simple reasoning of those needing to cancel. Okay, so the only way to cancel is one's up top and one's on the bottom. Do you know how many hours, so right now that's the unit of time that we have, our answer has a unit of seconds for time. Do you know how many hours there are, or how many seconds there are in an hour? Or let me ask this question. Would it be easier to remember how many minutes there are in an hour? We know that's common fact, right? So let's, instead of going straight from hours to seconds, let's go hours to minutes. And that's the idea here, guys, is we understand the process that we're going through on the board right now. We shouldn't have to memorize all of those facts on that handout, okay? We should know just our basic ones. 60 minutes in an hour, 60 minutes in a second. Does that make sense? Or sorry, 60 seconds in a minute. And we don't need to remember the fact that there's 3,600 seconds in an hour, okay? We don't need to understand those uncommon conversion facts if we understand this concept here, that we're trying to go from a unit of hours to a unit of seconds. Well, it makes most sense, I think, for people on our way from hours to seconds to pass through minutes first. Okay, so for every 1 hour, 60 minutes. So now if I multiplied everything out, the top would have feet as a unit. That's what I wanted. But the bottom is going to have minutes. That's not what I want, but it's closer. We went from hours now, and now we're in minutes. And is there a conversion factor that allows me to go from minutes to seconds? I put minutes right there. Okay? Those will cancel, right? Is there a link between minutes and seconds that we know? 1 minute for every 60 seconds. And now if I multiply straight across the top, I'm going to erase my statement there. If I multiply straight across the top, it's going to be 35 times 5280 times 1 times 1. But now if I look at the units, the only unit that would be left on top would be feet, right? Now if I move to the bottom, that's 1 times 1 times 60 times 60. And the only unit that I haven't canceled out on the bottom would be seconds. Is that feet per second, like we have right there, if they're asking for it? Okay, so if I multiply that out, it is 51.3 repeating. So it looks like this. We had 35 times 5280. And then on the bottom, we had 60 times 60. I'm just going to write it this way, 60 squared. So I get 51.33 repeating feet per second. So let's talk about what that means. What? Yes, yes. So because of that 60 times 60 there on the bottom, okay, if I would just look at 1 hour over 60 minutes and 1 minute over 60 seconds, that would tell me that in every 1 hour, there's 3,600 seconds. So that could be a conversion fact that you commit to memory if you want. So knowing that conversion fact would actually, yeah, it would shorten down this multiplication. I could get rid of those two and replace it with just 1 hour over 3,600 seconds. Okay. In the whole grand scheme of things, you got to then balance the payoff to that. The cost and the payoff is, okay, now I'm going to commit to memory one more conversion fact. Is that consumption of memory worth what I'm getting here and by basically cleaning up that one product? Okay, and that's, you have to judge that kind of for yourself. But what this means, guys, is that if I am traveling in a car at going 35 miles per hour, and I put it on cruise control, okay, then what this is saying is that for every second that elapses, every second that you are driving at that rate, you're covering 51.3 repeating feet. That kind of make sense? Okay. Now, it's the same rate, okay? It's just being able to realize that speed in different units. Okay, so somebody that's traveling 35 miles per hour, put it on cruise control, put a car right next to them traveling at 51.3 feet per second, put it on cruise control. Those two cars are nose to nose the entire distance, the entire trip. Okay, they're traveling the same exact speed. Oh no, one got a flat tire. All right. So this one says, the janitor at a school discovered a leak in a pipe. The janitor found that it was at a rate of 19 fluid ounces per hour. So here's the idea. Maybe he goes to the science teacher and says, hey, give me a graduated cylinder. Okay? I'm going to set it underneath my leak. And I'm going to put a timer on it for 1 hour. And when I come back, it's got 19 fluid ounces in it after that 1 hour. Does that make sense? So now he can use that ratio to help him decide how many gallons he's going to be losing a day. And we'll talk about, when we get an answer here, how that information could help him. So he's saying 19 fluid ounces for every 1 hour. That's the ratio that they give us. That's the rate that they give us at the beginning. Okay? We want to see what is that equivalent to in gallons per day. Okay? So I need to multiply. I always need to multiply these things. So right now, my unit on top, my liquid volume is ounces. So if I want that to cancel out, what needs to go right here? Ounces need to go right there, okay? So now here's the question. Are ounces at all related to gallons? Yes. How? Okay. So 1 gallon is equal to 128 ounces. Okay? That makes sense? And that's on that sheet that I gave you. It should be on both sides of that sheet that I gave you. Okay? So now the blue ounces are going to cancel out, and what you'd be left with is gallons per hour if I just multiplied this out. Okay? But I want gallons per day, so I'm going to try to get rid of this hour unit. So if that's hours, what needs to go right here? Hours. And then is there a link between hours and days that we're aware of? So what should I put here? Okay. It makes most sense to put 24 hours in 1 day right there. Now, if you did it, you about said, so it would have been blank hours over days, right? You could put 1 hour here. Okay? But 1 hour makes 1/24 of a day. Does that kind of make sense? So you would need that fraction there on the bottom, which really isn't that, I mean, it works. Okay? All of that will work. But you got a fraction, it's called compound fraction. It's kind of a nasty thing to deal with. So that's why I always say let the bigger unit, days would be a bigger unit than hours, right? So let the bigger unit always carry the 1, okay, the unit, and then let the smaller unit carry the, in this case, the 24. So now if I cancel those hours, I should have across the top gallons, and across the bottom I should have days, right? So it's just a matter of then multiplying those things out. So we're going to take 19 times 24, and that was divided by 128, right? So it gives me 3.56 gallons per day. 3.56. Now here's the reason maybe a janitor will want to know this. Janitor's not going to sit. Maybe he can't get the supplies to fix this leak until tomorrow. And he's going to leave tonight at 3:15 when everybody else leaves. And he wants to know, okay, how big of a tub do I need to put under this leak so that when I come back in the morning, I don't have water all over the floor. Does that make sense? So at this stage, it's saying, okay, 3.56 gallons per day. So as long as I put something below my leak that is bigger than that, I should be okay. Does that make sense? So you put the 5-gallon bucket underneath that leak, he's good to go, and he'll be guaranteed that tomorrow he's going to have a bucket that he's able to empty and there's no water on the floor. Okay. Same thing how you've ever filled something like if let's say that you have a swimming pool, okay, or maybe you don't have a swimming pool, maybe you all got bathtubs, okay. If we understand how fast our swimming pool or our hose to our swimming pool is filling our swimming pool up, okay, and this is an easy thing to figure out. You take a 5-gallon bucket, you put a hose into it, you start stopwatch at the same time, and you wait till it fills up, and you click the stopwatch. Okay, and that tells you how fast your hose fills up 5 gallons. Does that make sense? Then you put your hose into your pool, and now you're not going to sit there and watch it, are you? Okay, because it's going to take forever. Okay, so you do a little bit of calculations with that data that you found by filling up the 5-gallon bucket, and you can determine, okay, I need to come back. If my pool is 25,000 gallons of water, and I'm filling up with my hose, I could come back in, 52 hours, and I will be able to close off my hose, shut off my hose, and I'm not going to have water overfilling my pool. Does that make sense?
Yeah, how big was that pool?
Like a 25,000 gallon pool is, it's average. Okay. So the next question, so that's why we use these rates, guys, is so we can use a little bit of math in our everyday life so that we can maybe free ourselves to go do something else. You guys have any experience with like water pumps or anything like that? Anybody?
No.
If I've got a water pump, and I'm just going back to swimming pool idea, if I got a water pump and I'm trying to pump out my swimming pool, or anything that I'm trying to pump water out of, okay?
Or like a sump pump?
Okay, sump pumps are the same way. Yeah, if I've got a volume of water that I need to remove, and my pump has a rating of like 50 gallons per hour, or usually it's a lot larger than that. Let's say 500 gallons per hour. Okay, and I know that my swimming pool is 25,000 gallons. I can do a little bit of math here to figure out how many hours it's going to be before the swimming pool is empty. Does that make sense? Now, I'd want to know that because I don't want to just say, okay, well, it's going to be empty in 15 hours. I'll come back in 20 hours. Because then I'll have 5 hours in which my pump is running with no water in it. Does anybody know what happens when your pump is running with no water in it? What happens to every machine that is moving with parts in it? You create what? When things are moving and rubbing together? Friction. And friction creates heat, right? And when your metal parts of that pump start to heat up, they start to expand, and then they'll seize together, which means they don't have any room to move anymore, right? And you ruin your pump. Okay, and that can be hundreds to thousands of dollars, where if you would have done a simple 30-second calculation, you could prevent that. Okay, I don't know if I told you the other day that there was I think it was the early 2000s, maybe late 1990s, someone filled up a 747 they didn't realize that they were filling it up with liters, they thought it was gallons, okay, and that airplane took off and was only able to make about a fourth of its journey before it had to make an emergency landing, okay, where, they're lucky enough that they were able to make an emergency landing and not a crash. But it's all about being able to make quick calculations to avoid things like that, situations like that. This one here, I'm at the grocery store, and I have 2 tubes of toothpaste. You got that small tube, and then you got that really big, like family-sized tube. And I got to know which one's going to be best, because if I'm going to brush my teeth, I'm always going to use 8 ounces at some point, right? Okay, unless it's the summer or the weekends, right? Brush your teeth during the summer?
Yeah.
Why?
Never home, man.
I told the last class, I said it to the last class, I said, you know, you're always going to need toothpaste unless it's the weekend or summer. And they all looked at me like, what are you talking about? I'm like, you guys don't brush your teeth during the weekend in the summer, do you? And they're like, yeah. I was like, oh, I must be missing the boat on that. Like, I was trying to make the joke that I don't. And then I told them, well, it's not the weekend. I usually brush my teeth on the weekends. It's the weekdays. I save toothpaste that way by not brushing on the weekdays. Right?
That's how it is, though.
I don't get it.
Never mind. Just brush your teeth. That's messed up. All right, so this is a consumable good that you're always going to need. That's what my argument is here. Okay, consumable good that I'm always going to be using. So at some point I will go through 8 ounces. So I have to make the decision as a consumer. Does it make more sense right now on this day to buy the 8 ounces, or does it make more sense to buy the 6.2 ounces, run out sooner, and then have to go buy 6.2 ounces again at some point? So what we do is we determine what the unit price is. So I want to figure out what it is per 1 ounce. So what I'm looking for is a cost per 1 ounce. Okay? Well, in order to do that, this is very easy. I take the price of $2.59 and divide it by 6.2 ounces. And when you do that, it actually converts it into some number, and I believe it's $4.417. Okay, so it's 41 cents for every 1 ounce. Does that make sense? 41 cents for every 1 ounce. If you were to multiply that 41 cents by 6.2, you will get the 2.59 value. Okay? So let's say for every 1 ounce of toothpaste in this package, I'm paying 0.417. Okay? Now, if I want to find the unit price of the 8 ounce, I'm going to take 337 and divide it by 8 ounces, and that gives you 0.421 per 1 ounce. So 42 cents per 1 ounce. Well, which one's a better purchase for me if I'm trying to save money? 6.2. Okay. This one here cost me 41 cents for every 1 ounce. The one below is 42 cents for every 1 ounce. Okay. So I'm saving a little bit of money with 6.2 ounces. Now, that's kind of maybe different than an actual situation in the grocery store. Usually when you buy in bulk, so you buy more, you usually pay less, right, per unit. And the reason for that is you minimize packaging, you minimize shipping, you minimize all those external costs that the consumer takes on when you buy smaller packages. Okay. I'm going to skip this one here. I think the only issue here, it asks you to go length to width, or width to length. So some people are writing like 42 over 86, so they're getting the width to length ratio backwards. They want 42 to 86. So like I said, some people are writing it 86 over 42. Just be careful on how they say width to length. What is the ratio of width to length? So it's going to be W over L. And then if they got that right and still missed it, it's because they're not typing it as a simplified fraction. There's a factor of 2 in both those that will cancel out. Okay? And then I look at 21. That's 3 times 7, right? Yeah. If 43 is going to cancel with 21, then it has to be divisible by either 3 or 7. And 43 is not divisible by those things. So 21 over 43 would be the only answer I can have there. A lot of wrong answers are 86 over 42 or 43 over 21. Okay? So just be leery on how they ask you to write your ratio. All right, this is another one. This one here, guys, is a very comparable question to what you would see on the end of course exam. This is how they like to write their question on the end of course exam. Instead of just giving you straight up a ratio and asking you to analyze it, they give you a story problem, they give you context, and you're supposed to pick out the numbers that are useful to you and then develop the ratio that way. Okay? So it says, of the 77 unprovoked shark attacks recorded worldwide in a particular year, 29 of them occurred in the waters of a particular country. The bar graph below shows the breakdown by region of that country. what is the ratio of the number of shark attacks in region A to the total number of shark attacks in the other 7 regions? They give you a lot of information here, some of which is critical, some of which is just garbage. That is critical. What's the ratio of shark attacks in region A? Region A compared to the other 7 regions. Okay. I also need to be able to read graphs. Okay, this is does anybody know what kind of graph this is called? Bar graph. All right. So we got a bar graph here. Now, if this is 4, that's 8. Half mark would be 6, right? So that would be 7. So the region A has 7. Region B has 4, 4, 4. F is going to be 3. G, 3. H and J are both 2, right? Okay. They want, and this is where this statement here becomes critical. Region A. How many were in region A? 7. How many were in the other 7 regions? 16 plus 6 is, sorry, 12, sorry, 12 plus 6 is 18. Plus 4, 22. So that's the answer they're looking for. 7 compared to 22. Now here's where people make mistakes. Is that they instantly read this and they say, okay, region A is 7, and they compare it to 77. Okay, because they gave you an unimportant value in the beginning, right? They give you extraneous information. Okay? Or they take 7 and they compare it to 29. Okay? You need to understand what you're comparing A to, the other 7 countries. Okay? So a lot of the errors that I'm seeing are 7 to 77, 7 to 29. Got to be 7 to 22. If I take 7 plus 22, does that give me the 29 shark attacks that occurred in this country?
No, yeah.
Yeah. Okay. So those are the types of questions, guys. You know, this unit price question, this question here, you know, even maybe this janitor question. Those are the types of things that you're going to see like on an end-of-course exam where they ask you to use ratios and have an understanding of ratios. Okay. All right. I'm going to